Okay, should be live here. Let me real quick see if I can change the Twitch stream category. Again, right? Category. Software. Nice. Alright, so live. We've got it's only 10 somehow. I thought I was slow this morning. It's only 10. We have lots and lots to do today. Ideally with the microphone in a position that makes reasonable sense. Didn't get the best sleep last night. Didn't run the best 10K this morning. Didn't lift the heaviest weights, but we got it done. We'll get better sleep tonight. For now, though, I feel reasonably rested enough to tackle this. Provided we take this reasonably. So let's first of all we stop this. Let's put this down, like, yeah, here. Perfect. Okay, so we got 500 experiments off of this. We got 500. We're going to so now we have our logs for 2 ends. Actually, you know what? We don't even have to think about this yet. There's no thinking required yet, right? There's no reason to bother. Let's do the non-thinking work first as a warm-up. We'll do the analysis from last night. Blackjack Puffer going well. Expect a PR. Okay, cool. Thanks, Anish. Blackjack will be a fun end, actually. I assume Puffer just, like, wrecks that, right? Actually, Puffer will probably cheat. It depends if it's, if the way you set it up, if it's a full shuffle, like, if it can count cards or not. Okay, so right, the way we want to do this, zip, maze.zip, I don't understand what's going on, but all the best. This is reinforcement learning research done live. We are currently working on a type of exploration algorithm that uses the ability of simulators to jump to any particular state that you've previously seen. This is intended to be a 2-week research sprint, and in literally the first day, we got state of the art. Implemented state set on Inferno. Protein actually prefers both. Yeah, Valo. So, the bar for this, can state sets match a manual curriculum? I'd be very happy if it could do that. Like, let's say that with no curriculum, you kind of just get wrecked, and then this thing matches manual curriculum. That's already good. Poker is my dad. Yeah. I just thought that would be very funny to do, you know? Like, he plays your classic Hold'em, like, just constantly. I thought it'd be pretty funny to see, look, the model's better than you at the game in 30 seconds. That's what I'm trying to figure out. Yeah, Valo. There's still lots of ablations and things to run, mind you. Sweep for 12 hours. Yeah. I'm pulling, this is what I'm doing right now. I ran sweeps on mazes, and I'm about to pull the results in. Yo, hello. Swept is pretty fleshed out, so it's not going to be easy to beat. If it does, it would be huge. That's the point. How did it work out yesterday? We nailed it, Tim. At least I think so. We're going to pull the results right now. This is not going to have the params at first, but we'll do this to start. Do we have this stupid crypto spammers again? Ignore that. There's no token. Casual algo. I mean, it's not casual. Like, I've been thinking about this algorithm for months. But it was in an afternoon, which is pretty cool. See the stars. Uh-huh. This is laggy, which is weird. It's not supposed to be laggy. Okay, so we've got base. And we've got CL. Uh-oh. Huh, is it the same? Doesn't look like it, because look, there's only a few points. Go to score. What about model size? Okay, so this is interesting. Look at this. This is solving. So this is num layers. Hmm. We really should put the number of parameters on here, shouldn't we? This is definitely solving with way shallower nets. I just Carpath is kind of washed-ish. I think he's just kind of gone nuts. Like, presumably he has enough money to not have to give a shit. The algo or the env? It is the algorithm, but it's assuming state sets. So it's an env change to support an algorithm change. Okay, this result is like, If I do then scale. Okay, hang on, wait. This is still quite a big difference, isn't it? But how is it solving? I don't believe that the base algorithm solves this. That's the thing. Okay, this is interesting, right? Look at this. So with the base, no, there's no way that this is solving, right? With barely any prioritization. Like how, right? And then look, it's all highly prioritized over here. You know, we should also just include the CL frac, shouldn't we? Let's just do that real quick. like this, right? We had 4 params. And we added 4, so this is now 29. Okay. Okay. So, you get more. I mean, I would assume he made a shit ton at Tesla already, no? Like, I would assume he doesn't need more cash. I think the guy's just gotten kind of loopy and thinks Anthropic's actually doing stuff correctly. Like, Anthropic is the out-of-touch company. You go there when you're completely fucking out of touch. State buffer size versus perf. Let's do... N. What's this? 2E5? E5? Wait, huh? I didn't think we could go that low with this. Oh no, E5, that's 280k. Okay, so anything like 280k plus is fine, it looks like. It actually looks like smaller buffer's kind of better here. 280, okay, so that's cool to know. CL frac, look at this. So, it's kind of interesting, actually, if you look at it this way. If you give this thing access to curriculum, it doesn't look for the solutions that don't use the curriculum. So you would think that that would mean the curriculum is pretty immediately useful. Like, look at this. Anything, this is like 40% plus of states. Oh, this is weird. I don't know what to make of this. Most of the runs are very low prioritization. And then this we didn't sweep. What was our default on this? Would it have been like this point out here? I think it's probably like one of these, like probably this point would have been our baseline. And there are definitely some weird things going on here. Let's just do... Okay, wait, actually, this is fun, right? So we have... What do these points represent? These are all experiments. This is a morning analysis of overnight experiments and trying to see what we figure out from this. Hello, welcome. It's very weird in some sense, right? Like, the data is much messier from the non-curriculum learning one. But then somehow, according to this, it's finding, like, solves. Do I believe this? I mean, we can just go run this real quick, right? We have to go watch some policies, I think, because that's kind of ridiculous. Like, I don't know if I believe that. Oh, also, no, we know that this thing is good. Okay, I forgot to tell you guys this. So let me explain something. Let me sort of, like, put into perspective what is going on here. So yesterday we ran some initial experiments on very hard mazes, and it looked like we were just crushing the baseline, right? I ran hyperparameter sweeps overnight for both of them, and the curriculum learning method is very good, but it looks like the non-curriculum learning method can still solve the task. And it can solve the task, like, way better than expected. It should not remotely be able to solve that task. But then I remember last night, I ran this on 2048, and we got a new state-of-the-art on 2048 as well. And 2048 is, like, a very high confidence task for us. So, I mean, it would seem to me that there is still something here. Like, there's something very good here, but it's a little complicated what's going on. I think that's probably what it is, Tim. I think that Puffer 4 is just really, really good. And, like, you just need some stupidly hard problems to even test things. Because once you run a hyperparam sweep, like, Puffer 4 kind of just solves a lot of stuff you would expect it to not be able to solve. Yeah, but this is right here. This is state-of-the-art on 2048 under, after the new end fixes on 4.0. And it's in way less time as well. This is like a third of the time as the previous best solution and a few hundred points higher. And mind you, this is actually with a smaller model as well. I think there is definitely something to this this algorithm we've come up with. All right, so let's first start. Oops. We start like this, right? And this is a super sketchy solution here. Wait, num maps, map size. Uh, Hang on. It looks like this was here before. This is okay. It's the map, the starting size. Fine. Recent 2048. Yes, I do. I have the one from 4.0. And if you compare on the website, here, I guess I can bring it up while this thing trains. Okay, so if you look at 2048 here, and you go to score, 14,329 in 19.66 seconds. Okay, it wasn't a third of the time. I guess we'd be like right out here. So we would have this point would be near the other points that are like 12K score. And we are 500 points higher than our best ever run. Oh, wait, maybe... Okay, admittedly, I think this might have been on a 4090. So maybe it's the same amount of time. It might be the same amount of time, but I do think it's a smaller model as well. I've noticed that. Huh? Hey, let me copy my data point. Yeah, look at this. So this is a 10 million parameter policy. And we just did it with a 3 million parameter policy. Was there a bug? There was a while ago, like with the way that we were handling stuff. We had one of like the 2048. There's a community of people that write scripts on 2048, and they said like, hey, you've got this thing with the way you're handling resets. It was a subtle difference. So we changed that, and it made it a bit harder. Okay, so this gets us 41. So that's interesting, right? This parameter set was supposed to get us 47, but it actually only gets us 41. It's still ridiculous, though, that you can do that. I guess we could make the benchmark bigger. Let's see if that's likely to do anything. Does it make sense to make the benchmark bigger? I mean, it kind of does and it kind of doesn't. $2048 is definitely a good end for this. We should definitely weight that result quite heavily. Oh, well, this is interesting. We're at 128 horizon, aren't we? Hang on. $512? Wait. Hey guys, this thing is now sweeping. It's sweeping longer horizons to solve this. And actually, the best data points we have significantly are at shorter horizon, it's using curriculum. It is noisy though. It's quite close. I don't want to make sure. I want to make sure we have clear trends. Actually, out here, look, it's all the. Like, some of these good base runs are all the way out here. That's cool. We're doing very long horizon stuff. That's a tiny number of steps as well. So, like, we just got massive sample efficiency somehow at the same time. I mean, look, clearly Puffer 4 solving the task in a minute would mean that we don't have a hard enough problem. I mean, this seems like a crazy hard problem to me. What was this one that I grabbed? Because I grabbed, like, a reasonable point. Okay, look, this is still pretty highly prioritized. So it's using the implicit prio. Obs and action spaces. Action is just, like, move left, right, up, down. Obs is a crop of the nearby tiles. Let me think about if this task is really, if I've set this thing up optimally. So, I mean, the point of this update, right? Like, the motivating example of this is really long horizon tasks, where when you fail, you go all the way back to the start. That's like the classic example. I actually, maybe the sameness of mazes makes it bad. I mean, I wouldn't be surprised if it's just like Puffer 4 is learning a really good general maze solving algorithm quickly. Right? Yeah, that would definitely explain it. Okay, so I think we need to just think harder um about tasks then that we use for this. What's like, we need some sort of nice progressive task. The simplest form of this is just like entering a code, right? Is that a reasonable environment? So the environment is just, you have a code. You have to enter the digits of a code. As soon as you get a digit wrong, you go back to the start. Yeah, because then there's no sameness in the structure you can exploit. So that would be like, that would be a more convincing test. That's a simple enough environment Codex can implement it. Hello. I'm trying to think if there's anything I'm missing here with that. I think we try it. Let's just go see real quick. Because we can't use this end, this incremental env. I mean, as crazy as it is that this thing is solved. The horizon, and like the increased horizon is very encouraging to me, though. Because, like, look, without the horizon before, it's very bad. Wait, how does this make sense? Isn't the baseline... I thought I had a baseline env. Wait. I had a baseline that should have done better than this with only 64 horizon. And that's... Oh no, Maze is 256 Horizon. Okay. I hadn't noticed that. That's actually a really cool thing then from Puffer 4. Okay. Okay. We'll have to merge in those new kernel changes then from the guys that have optimized this for us. Hello, welcome. Hmm. Does that sound like a reasonable environment proposal though? Just like a passcode environment? We basically, like, Puffer is so good at this point that we just need to give it fewer things to work with. I think that makes sense. And then if it does better on this, then it's still, like, that solves a problem, right? And we can sweep it on other ends. Specific ends. Do you really care? I mean, you go train that LLM with millions of dollars of compute, and we train our models in seconds or minutes on one GPU. I'm trying to think if there's a better environment that I could use for this. I mean, this is obviously a dumb synthetic task. Um, to be fair, I've had versions of this passcode env before. I had never actually thought of this as a as like a state set test, but I think it's a good one. Okay, this is fun. We'll go play with this to see if this is correct or not. Super simple env, right? 150 lines. I think it could be even shorter. Yeah, and then this success we also don't need. We'll refactor that, but let me get this initial thing first. This task intentionally does not require memory. Kind of funny that it actually realized that it should do this. Yeah, we'll comment this thing out first. Ah, forgot about that. Would have been bad. Okay. Well, this thing trains super fast. So okay. God damn, man. It's like keeps adding this stupid extra character at the top of my file. Dude, this does worse. Oh no, it matches. Huh. Arguably, at the very least, I could run a quick sweep on this, right? Like, this wouldn't take very long. And do 64 length, right? Still be fast. So annoying. Oh. Not sweeping the mini batch sizes and stuff's a little iffy. Hopefully we have checks on this. I think we do. All right. That'll do. And all right. We'll give this a quick sweep. Presumably this doesn't take very long. We'll start thinking about some other things as well. This. Make sure that it still works. And, Okay. We're starting to get experiments coming in here. They're quick little experiments. Hopefully it'll run longer stuff, we will see. I'm gonna go use the restroom real quick. Should also grab my my vitamins for the day. So we'll let this get a few runs in. And then we have still quite a bit of stuff to do, right? Let's take a quick look before I do that. Oops. Yeah, so I think that we're here right now, right? Dedicated test environments. We have some good initial results. Um, we definitely need some stuff on test environment. We need this test environment first. We get signs of life on this, and then we can consider algorithmic ablations from there. Cool. I'll be back in a few. Wait for Puffer 5. Let me make sure these experiments are going. One other thing I gotta do real quick. Folks still watching, do start Puffer on GitHub. It's free. It actually helps us out a ton. It means I have to spend less time advertising my stuff to companies, and then companies to come to me for professional stuff. And I get to spend my time here streaming. Okay, we already have 200 experiments on password, so that was quick. Oh, and it's solved. And 45 million steps. Yeah, I think Puffer is just too good. And 28 seconds as well. Okay, we have to relaunch these with something harder. Like, I'm genuinely having a hard time coming up with tasks that aren't just bullshit that Puffer doesn't solve at this point. Okay, with 256, I will not be surprised if this still solves. If it solves in 45 million steps, though, we just have AGI, whatever. Like, you don't even need Puffer 5. It's just AGI. Well, do you understand why this password environment is ridiculous? It's like, guess the password, right? And I'll tell you if the leading digits are correct, but then you have to re-enter the whole thing every time. So for like 256, right? To get your one bit of information, you have to go through 256 steps. So I'm basically just trying to come up with environments where, like, you have to redo all your progress every time you make a mistake, because that's the ideal case for state sets. Did it just cast a fireball? True. It's not AGI until it casts fireball. Let me go get my vitamins. All right. 1 mil SPS with 4K agents. No, it's way more than 1 mil SPS with 4K agents, man. We can hit 10 mil with 4K agents. Maybe higher than that. And yes, Puffer is a research lab. I'd argue it's the best research lab in this specific type of thing. I stream all the dev right here. It's a fun time. All right, so score of 46 so far. Yeah, 46 so far is the best on this. 10 mil? With 8K agents, we hit 20 mil. That was the main result from Puffer 4. Our public release, we solved Breakout in about 4 seconds with 8192 agents and a small but non-trivial architecture model. Number one. I mean, number one research lab in, like, Tabula Rasa RL, yeah. You can go ahead and compare Puffer to other things out there if you'd like. Particularly if you care a lot more about, like, infrastructure and, you know, large-scale testing and that sort of thing. We don't come up with the fanciest, like, you know, the fanciest ideas or any sort of crazy math or anything, but we make things work incredibly well. Hey, Jess. So, the finding from overnight was that the maze task was too easy because the curriculum model shredded it, but with enough tuning, the baseline was also able to solve the same task, and the results are kind of comparable. I think what's happening is just it's learning the substructure of mazes very quickly on the smaller ones, and then there's just not really much to differentiate between those two models. So essentially, it was just a bad choice of tasks for this one. There were some advantages. It looks like there were some reasons to prefer the curriculum version over the other one still. But we just need a better task. So I have this new task. The task is called password. The way it works is there is a 256-digit password, and you start entering digits. Every time you get a digit correct, you get a reward. As soon as you get a digit wrong, you get a negative reward, and the entire thing resets. So essentially, you know, you are forced to repeat the entire trial up to where you failed. This should be a good task for state sets, I would imagine. It's actually kind of funny when I think about it, right? Like, in order for state sets to be better here, we'd have to set very low horizon. So, I don't know. We'll see. We'll start with this and we'll see how it goes. Does anybody else have any ideas for, like, similar types of tasks we could use that would be simple to implement and would be better in any way? Like, the point of state sets, right? Well, there are a lot of points to state sets. It's a very powerful curriculum algorithm, but the cleanest, easiest to see description of why you have to have state sets is for long-running problems where making a single mistake makes you start from the beginning. That's, like, the most obvious use case for it. Now, I expect what's going to happen is if we tune this thing to be very good on that case, then we're going to just see it's going to just be better across the board on a lot of ends. And we'll be able to measure all that, but we need a good, clean task setup first. Puffer LLM. Nah, we don't have any Puffer LLMs. We do real science here. Okay, there it is. It's starting to learn here. So, oh, come on, 16 seconds? Yeah, 16 seconds. It solved 80, length 73. Cool. Well, all right, let's look at the main stuff we've got on Puffer 5, and I'll kind of just talk through this. It'll take a while to get a reasonable enough sweep for the baseline, I suppose. So, refactoring environments to support settable state. Honestly, as long as we have a before and after for each of these, Codex can literally do this. The bigger M's, I'll have to make sure it doesn't make a mess, but like, this is a very, very simple refactor. Multi-agent integration. This is done for fixed numbers of agents per env. It turns out that the drive environment could be modified to have a fixed number of agents per env. There are not that many cases where you need variable. I mean, it would be nice to have, I suppose, but like, it would be nice to have, but this is just a pain in the ass. And I don't feel like messing up the code base. I'm going to say no on this for now. I think this is not worth it unless we have a really, really important env that needs this. Dedicated test environment. The password env should cover this, I would suppose. I think, like, password on its own, if these experiments work, like, this should be the cleanest possible test case. It doesn't require memory. It doesn't require anything else other than state sets. Solved versus remaining exploration problems. So, yeah. I said I think that this solves curriculum learning. This does not solve all of exploration. So, I think that the remaining thing is going to be environments that, or algorithm that gets good state coverage. So, like, let's say we just delete all the rewards. Do you cover states? Like, do you cover all the states or whatever? The state coverage is a remaining problem. I don't know if I want to start that. I don't know if I want to start on that. I don't think that needs to be part of Puffer 5. I think we keep Puffer 5 nice and small and concise. Ablations and sweeps, we're already doing that. So, right, but the main ablations I have in mind, we need to know how big of a experience buffer is required across different problems, and we need to think about the efficiency of sampling. Our core course. Yeah, that, like, exactly, Jess. Curriculum learning is in supervised learning, how it works in RL, use M's make it progressively more difficult. Yeah, so it's a whole class of method sounds. You can do curriculum learning by modifying your training environment specifically to give it this, like, easier than harder and then harder thing, adaptively or fixed. The algorithm that we're working on here, it's intended to be a much more powerful and general method. It only requires that your environment have settable state, which if you're building your own env, it's very easy to do that all the time. That is the key realization from Puffer 5, is that this is actually not a big restriction. And it works by letting you jump right to portions of the environment where you're currently having difficulty or you're currently learning a lot. And it does this fully automatically. So that should be very powerful, and we're investigating that at the moment. Is there a paper? So this is a combination of very, very high level, what was done in Go Explore, prioritized experience replay, and advantage filtering from Go Explore. There are a couple, like, prioritized level replay type ideas in here, but it's very heavily modified. And it's done at the level of trajectory segments, not levels. So it's arguably the biggest inspiration is Go Explore, and then it's a combination of many other techniques, but it's like the specific combination of those techniques was already sort of in Puffer 4 and even 3, so it flowed quite naturally. Yeah, they've already had a million people ask me about that today, Jess. I have a very, very strong suspicion that a lot of the people that you see being successful that suddenly kind of go off the deep end, I think that SF just has a really big acid problem. That's kind of my guess. Because I don't know how the fuck else you explain this. I guess it could also just be like giant SF echo chamber. I guess that's also kind of a simpler explanation. But who the hell knows? I prefer to stay away from both. Yeah, I kind of figured, Jess. Okay, ablations. Let me talk through some of the experiments here. So, the main performance impact right now, the main performance problem with Puffer 5. I don't know who the fuck this is. Um, the main performance problem with Puffer 5 is simply sampling from the giant replay buffer. So we either come up with a way to make the replay buffer smaller or we make the sampling more efficient. Yeah, I don't really have a good solution to the Twitter thing, sounds like, because I have to put stuff out on Twitter every so often. This is where I get my clients and all of my brand stuff from. But it's truly awful, and I am both happier and more productive when I'm on that less. Okay, so smaller buffer or faster sampling. I have a solution to YouTube on your phone at least. Get one of these. You'll never watch YouTube again. Good luck watching YouTube on a Kindle screen. Yeah, it's too easy to turn that off, and also you can still watch videos on grayscale. This, like, the entire screen flashes and, like, warps and screws up if you try to play a video. It's, like, intentionally shitty. And also the keyboard, it's, like, such a pain in the ass, I barely use my phone. It's great. Actually, the only thing I use my phone for a lot now is Audible, which is exactly what I want. Okay, so it's either smaller buffer or faster sampling. Let's think about this. So the size of the buffer determines how long around a sample is for you to make use of it. The fewer fresh environments that you have, the slower it fills up. I mean, at that point, you just don't have a phone, Valo. Which, like, life goals, not having to own a phone, that sounds pretty great. All I would really need is a player for books. Yeah, I mean, realistically, right? Like, let's say it depends on the fraction of CLMs as well. Let's say that you have 1,000 fresh environments. It's going to be on the order of like tens to low hundreds of millions of steps backward reaching. And like, I suppose that's reasonably powerful. Hmm. I think rather than keeping a massive buffer, the most profitable thing for us is going to just be to figure out what stuff needs to go into the buffer in the first place. We could just put like the top advantage segments in. 10K. I mean, if we could get a buffer with only 10K starting states, right? I would I'd believe that you could do a lot with that. Because the thing is, we're not really using prioritized experience replay in the same way anyways. Okay, so like there's stuff we can do here. We definitely need we need like a clean benchmark to start with though, for sure. Let's see how this thing is going. Jesus Christ, man, 219. At least it's taking 186 mil steps. 44 seconds, though. That's nuts. 343 possible. Okay. We'll check back on this in a little bit once I've gone through the rest. So We did this single compilation unit. Cleaning up kernels and stuff is going to depend on what we do for the rest of this. I really want to keep 5.0 like as concentrated as possible of an update. But I think I'm going to help Spencer with some of the self-play. And then we just do a little bit of basic science type stuff. This is super simple. This is a bunch of experiments, but like this is like nothing to implement. Oh yeah, whatever happened to Aurora? Ivalo or Jess? That's what it was called, right? The new optimizer thing? You guys were working on this at one point, right? In Inferno. See, yeah, that's the thing. You don't do, lost your speed fix. Well, I'd like to have that, Jess, so I can play with it. So you don't go test the thing on Inferno. You test it on, like, our core stable ends. Like, 2048 is a good thing to sweep it on. All of these are, like, easy to play with from stable code, though. Should be a conflict flag. Once you're done with, like, the current Inferno stuff, absolutely. I would very much like to know whether you have anything with the state sets on the thing. Also, it is possible that I end up changing the state set algo quite a bit. Like, it's going to depend a lot on this password env. Yeah, see, it's still doing better. It's just gone up. It's funny to me that this gets such a high gamma for what's essentially a one-step credit assignment problem. I mean, I guess the other thing is there's room for quite a bit of basic science in Puffer 5. Like, I would like to understand a lot better the remaining gaps. Like, what M's are still hard for us, actually? Do we have any of these degenerate M's? Bandit problem. Memory test. Stochastic policies. I guess there are a few, like, simple M's we could come up with for understanding. The model has to guess the password. Yeah, I can explain the password env again real quick. So the password env works like this. There's one singular password. It doesn't change. It's a fixed length. It's length 256. You start at the very beginning. You don't observe the password. You guess a digit. If you get it right, you can observe. It goes into the observation, like that. Yes, this is the correct digit, and you get a reward. Then you guess the next digit, so on and so forth, until you get one wrong. When you get one wrong, observations get wiped, whole thing resets, but to the same password. So the idea is you have to try out digits, and like as soon as you make a mistake, you have to re-enter the whole password. So in order, like the optimal way to do this, right, is you just try every digit. You try every digit for each number, and um, like the annoying thing about it is you have to re-enter everything every time, so it takes way, way, way longer than if you could just try the digits individually. And this is where state sets come in. Because with state sets, you can jump partway through the problem, and you should be able to dramatically shorten the amount of time that's required. Okay, I like the idea of doing some sanity M's. You don't need to remember. So the password M does not require memory because you can observe all the digits you've gotten so far. Arguably, you could do slightly better at it if you remembered the whatever the like you've tried already on the current digit. But because you're doing this thing massively in parallel anyways, that's less relevant. Like, you have to realize when I make test environments like this, they're not meant to be realistic or fair. They're meant to expose specific flaws or like specific edge cases in the current algorithm. That's it. Reinforcement learning in form of what? SN, welcome. Oh, you do have to remember this. You do have to remember the password, don't you? Right, but you only have to remember one step, right? Yeah, you don't have to remember the whole sequence. You only have to remember... Easy memory task, card exploration. I like that. I think this is good. Anything else that we're missing? We go look at B Suite in the meantime. We have not gotten any additional progress on this. $468 possibilities. We'll give it to 500. And then we'll launch the other one. This is Ian's paper, which is like... delightful policy gradients, dude. Well, I shouldn't be so negative on it. I mean, he's trying this stuff. I just don't think metric makes much sense. And this was a good attempt for the time as well. Yeah. No, this was actually a reasonably good thing. The tasks are a little too arbitrary, but... yeah, see, this is... See, this is wrong right here. Because this is not a memory test. This is also a credit assignment test. We fixed that with the thing I just did. You bought a tiny box? I bought two. We have two tiny boxes at Puffer. They've got 6 4090s each. They were 25K a piece. So, decent pricing back then. Yeah, this one is stupid. This one is very stupid. I just want to see if there are any good environments in here that I haven't thought about. Bandit problem thingy. We'll think about this in a bit. This is trivial. This is trivial. This is trivial. This is reward scaling is a separate issue. We could look, actually, that is something we wanted to look into. But this is not a good formulation of it. Mohammed, you're listening to morons that are trying to sell you things. Yeah, I don't like this one. Is this credit assignment? Is this not identical? I had to learn something. I mean, what are you interested in, right? Like, I'm not gonna tell anybody who's not interested in dev to go do dev, because you'll just be a terrible dev. Like, I'm not the person to ask on, like, what's a stable job I can do that makes money. All the scripted opponents get one shot. No, you're unemployed. I'm not unemployed, Valo. Buffer has contracts. A small but profitable company. And I get to do all sorts of cool research with it. Learning to memorize which digit to place. Yeah, crit, but like the thing with the password env. Oh, actually, speaking of which, are we ready? Whoops. Who to out of memory? All right, that's enough of them. $251. Jesus. Oh yeah, look, 2 of the GPUs just died. Huh. Interesting. Okay, so apparently we do have some things to fix with that. All founders are unemployed. Fair enough. Tax write-off on the boxes. Yeah, of course, Jess. Any of the equipment we do is like any of the equipment you purchase for use for your company. All right. That is the new sweep going. We'll see what this does. Is there anything to this task at all? Yeah, I don't think this is really any different. We can ignore this one. Memory bits. Why do you need to cut calories? I mean, just like more casual training while I was finishing Puffer 4 and not wanting to lose muscle. You know, you gain some fat when you're not training quite as much as you normally do, especially if you're trying not to lose your muscle and strength. So, no big deal. I also PR'd the bench, so wasn't bad. No big deal. Easy 10-pound cut. And I'm basically just having like a bagel sandwich and maybe a soup after my run at like 10 a.m., like 9 or 10 a.m. And then I have a big bowl of soup for dinner, and that's it. Like a hearty soup, but still. Yeah, see, Vala, but you're probably doing it smart. I just like, you know, cut calories by 1,000 plus and say, yeah, sure, that'll work. £20 cut is a lot. I'm feeling hungry. I don't really I don't really get that hungry. It doesn't, or I do, but it doesn't bother me. No, cutting is just not that hard for me. Keto. A 20-pound is a pretty major. I mean, I try not to get 20 pounds up from whatever weight I want. Like the 16 pounds I cut last summer was some pretty nutty circumstances. I guess Sokoban is kind of the next task I'm super excited about, right? As a benchmark. Like, that's a really good, why the hell can't we solve that task? Yeah, I definitely don't just fast. That's, not a good way to keep muscle and strength. And I'm also not just, like, not eating and doing nothing, right? I'm still running 10K per day and doing some lifts. Well, we don't have a ton of runs yet, and we're only to 90. It's not great so far. I'll be back. Oh, look, it's already better. Okay. Well, we'll see how this goes. So, this looks like a reasonable set of things, though, for Puffer 5. This is nice sanity. Sokoban is just hard, isn't it? I mean, we'll get a better set of levels for it. Yeah, we'll get a better set of levels for it. Maybe we'll relativize the obs. We'll see. Okay, I guess we can think about the, we can, assuming that we get some reasonable thing out of state sets, which seems very, very likely here, given the earlier results. Um, Assuming this thing works reasonably. The ablation that we would run on prioritized experience replay, there are not that many of them. We'd basically just take the replay buffer, right? And instead of adding everything to the replay buffer, we would either sample or add like top K or whatever based on advantage. I think that would be reasonably simple to check. That would be reasonably simple to check. So if this works on password, then we have the next experiment to run. It'll require us to implement some things. If this doesn't work on password, well, then I think we have to go revisit some of the algorithm design choices because it really should. It actually would be very, very odd if it didn't work here, right? I guess arguably it would be the, like the important sampling correction could be off, right? Oh, so we would just re-implement the explore beta thing. We'd re-implement that annealing, maybe. Or actually, the CL frac annealing is the easiest one. Yeah, CL frac annealing is the easiest. And just sweep that. That's guaranteed to be... Okay, so we have a plan. We've got a plan. We're at 126, and how many runs? 136. And this is 60K steps. Let's see if we see any difference so far, I suppose. Thoughts on Chris Ola? Huh? Where does this come from? I mean, I haven't thought about that guy since interpretability work like many years ago. Follow. Another one determine. That's basically the same as, well, actually, I think that's worse than the password environment because the thing is, you'll kind of just quickly get the gist of the task, and then there's not really any more curriculum problem to it. Enduro is sort of like that. Okay. Oh, is this base? Well, that's not super encouraging. So far, it's doing better without the CL. Though it's not very far into the sweep. I wonder if we do in steps. Oh, it is much closer in steps. Interesting. So I guess it's possible that the inefficiency of the implementation is what's borking it. I'm gonna have to let this go longer. And in the meantime, Andre, yeah, I don't know what he's doing. On sweep, over from 3-0. Well, sweep has a whole bunch of stuff in 4-0, Pepper. Ten possible. I can just make it digits 1 to 4 if I want. Found it yesterday. Yeah. I mean, I don't know about him personally. I just know a lot of the Anthropic people are really out of touch. So I kind of just ignore any and all communications from that company other than just the model benchmarks. Yeah, Jess was doing that as well, Hassan. By all means, like... No, that's not going to be a good test for CL. It's like... You want something very self-contained when you're doing these types of things. BF16? Thank you very much, Spencer. We'll be merging that in shortly. We're getting some really weird stuff with the CL at the moment. I think something is quite wrong with it. We still have the soda result from yesterday. But I need to fix some things. Yeah, I think what we do is we let the current one run. And then we do annealing out the CL ratio. And then annealing out the CL ratio should give us... If we're biasing the training with CL, that would fix it, right? Or does it? Hang on. Yes, that does fix it. Wait, let's see. Why is it all the way up here? Well, something is screwy because state buffer size Oh, there you go. That's better, right? Okay, so I guess it's possible that the sampling is just really slow. Yeah, it's the same jest grid. You see, there is a peak CL frac. So I do wonder if this needs to be annealed. Very low explore alpha. Well, we know the next thing to run. I mean, I think this is going to be a pretty robust set of experiments. Um, so I made a new test end for curriculum, Spencer, because I think what was happening with the maze env is just like the agents were very quickly learning a general maze solving strategy, and then at that point, it like it doesn't really matter the size as much. So with this env, it's a very strict test of exploration in the sense that you enter a password one digit at a time. You have to guess each digit, and as soon as you get one wrong, you go back to the start. And you can also observe all the digits you've entered thus far. So the idea is with this one, you very, very clearly have to go back to the start every time. And I mean, if curriculum does not work here, there's something wrong. So the goal is to get a very strong result on this and then see when we sweep everything else with this, what happens. Yeah, so I think my current suspicion, it does seem weird to me that like biasing the data like that is a thing. Like this CL frac here, right? Oh, what? Wait, why is it all at 0.9? Wait, did this not sweep? Um, Wait, we have CL frac and sweep. Why does this start at 1 and then go to 0.9? Oh, okay, it's just the log screwing up. Now this is fine. Yeah, so right here, the fact that this is peaking at like 0.6. So yeah, I think even if it's not going to be the final approach here, um, we're going to need to anneal this fraction. Okay, also the state buffer size being screwy. This doesn't make sense. I think we just wait until we have a little bit more data, and then we analyze this, and then we run the other one. And if this takes some time today, it's kind of fine, because we sort of figured out everything else in the meantime. So once we have these results, we basically should just be able to plow through everything. I suppose we could just, like, shitty codex implementation the other ends, just to start with while I'm waiting for stuff. I don't hate that idea. Memory depth. Explicit curriculum it. Yeah, I think we just explicit curriculum it. think you don't want a -1 penalty. They get conservative, don't they? This is simplest. PR Aurora? Okay, great. I have lots of nice PRs now, it seems. I'm gonna wait until we have this current thing stable, of course. We're at 144. Yeah, this is not doing very well now, is it? What on earth is this chat? That's funny. Hmm. Yeah, very simple memory env, right? It's very concerning that the curriculum doesn't work initially on this task. Well, actually, it should be able to just set the CL frac to 0 if it's bad. So in some sense, this would have to just be a sweep failure, wouldn't it? Makes me think it's worth investing time on the sweep stuff. Find objective. Now we're doing something quite different with the CL stuff right now. This is just while I'm waiting. fine, this doesn't build. Huh. Oh, I wonder if, no, GPUs are all going still. 233, okay. I may as well get this done now. Why is he adding all this crap? Taking way too long. Hmm. Well, I mean, this definitely doesn't make sense, right? Because it could just push the CL frac down to 0. So in some sense, this is a sweep failure. Makes it worth a lot more like this means like a lot more is it's worth putting more effort into sweeps, I'd say. We just have so many hypers now. Hey, what's going on here? That makes no sense to me. My experiments, we're gonna do 500 each on password, Spencer. I suspect that we just have some small flaw. Um, I have follow-ups to this. I think it's the case that we know that there's stuff in this algorithm, but then there are just some failure cases that we need to handle. This should not be building for this long. Interesting. That's a sketchy thing. We'll just call it memorize. This is, to be clear, this is just a separate thing. This is not for credit assignment stuff. Yep. Hmm. That's funny. In discrete or continuous? Do it in discrete, Spencer. Continuous has been sketchy lately, and I don't want to conflate. Like, I don't want to have stuff screwing up because of that. Uh, yeah. How's Go Explore? We're running experiments at the moment. We gotta finish. There's something wrong with it. I mean, we have the soda result on 2048. But I think we have, I think we're gonna need to make some small changes to the algorithm. I think there's some silly failure modes. Yeah, see, this thing is still getting better. But this is gonna end up underperforming, I'm pretty sure, the baseline. No big deal, it's a pretty quick sweep to run. See, this is shitty code. So I see that there's a, like, if I look at this, I'll show you. Oh, come on, man. Oh, wait. Okay, here we are. So if I look at the fraction of environments that are being used for curriculum learning, there's this peak at like 0.6, and it gets worse if you go higher. So I think what's happening here, there's this sampling bias that's caused by setting environments to be using the curriculum. And the other thing that's suspicious is the value that it's finding for Explore Alpha is way too small. It's basically trying to avoid using too much of the curriculum, which I suspect is it's trying to balance using the curriculum with biasing the data. There are techniques to correct for that bias that should put our results at least way more in line with the baseline, because there's no way possible this should be underperforming. So it's a combination of knowledge about the algorithm, knowledge about various techniques, and just kind of looking at all this stuff fresh and keeping it as simple as I can. That's shitty code. Markdown of the algorithm. I haven't committed it at the moment. I suppose I can show it. No, this is not it. Well, I wrote this. This is pretty much the current algorithm. It's mostly just these points here. So you initialize a buffer with a number of states. Every time you do rollouts, you store states to that buffer. You store the advantage of those states during training. And then every new rollouts, you sample some of the environment states from that buffer based on the advantage. And then most of the questions are like around how do we correct? Do we need to correct for bias introduced by this sampling? Do we need to do anneal shit? So on and so forth. Palo Alto, it's cool for now. PC, what? The sampling, it's the prioritized replay sampling. And then as for correction, the correction is just going to be the basic like beta term in importance sampling and or annealing the CL frac to 0. This is making progress, but it's just not very good. No, it has a literal meaning here. The literal meaning is you're changing the distribution of training data away from like the distribution that you expect training on environments from scratch. Like the state set distribution is different from your normal training distribution. It's the same thing as prioritized experience replay needs to correct. Scheduler for the amount of environments. A little different. Cover paper. Hassan, The research thing that you sent me, like that looks like it's LLM gen. Is that LLM gen? Because I'm not just reading like a massive LLM gen thing. That shouldn't matter, but whatever. The heuristic? Huh? What's a heuristic? Also, how close are we to done here? Okay, 60% of the way done. Yeah, this is not great, unfortunately. I do wonder how much of this is just going into the buffer samples, because it's using like giant state buffer. Seems odd to me that it would do that. Yeah, there we go. Cool. That doesn't, like, the statement you're making makes no, like, those words don't go together. We'll call this at least partially reasonable. I want to think about the stochastic policy env. What's a basic env we have that can have like an extended stochastic policy? Stochastic policy env. I want an env where the optimal policy is stochastic and non-trivial. So like rock, paper, scissors, it's stochastic, but it's trivial. I think I had one, didn't I? I don't think the optimal strategy is stochastic. No, it's not. The optimal strategy in blackjack is not stochastic. Package delivery? Why would that be stochastic? I have an old implementation of this. I think I do. We're using PER. Because search massively fucking blows up your compute to the point that, like, you can no longer do anything reasonable at small scale. Search is like this huge fucking massive blow up in compute. Adaptive enemy that with non-observable strategy will do it. Yeah, Jesse, that won't be stochastic. That'll be deterministic conditioned on the current obs. Is optimal. Oh, actually, this is simpler, isn't it? Yeah, this is simpler. Alright, surely that bought us some time, right? Okay, this is getting slow. It is getting better, though, so I don't really want to kill it. 172 now. Poker or go? I actually have no idea how hard poker is. You don't need search for poker, do you? I don't think so. Um, Go is very hard because Go has been done with search with a fucking ton of compute. But we're doing chess decently so far. Yeah, I think that there's still some stuff to be done on the self-play, the sampling and stuff, though, Jess. Nolan Brown says you need search. Like, need based on what? I don't believe that. Like, why the hell do you need search for chess, but you don't need search for Dota? It's probably, what, like 1400? I mean, but this is training on, like, a GPU or a machine. Dota is instinctive. No, it's fucking not. Are you insane? Dota's a hell of a mix of different stuff. That is a batshit hard environment. Yeah, I have not seen any version of search that I've been convinced is compute efficient. That's the problem. Okay, cool. This is what we wanted. Yeah, I've not seen any version of search I'm convinced is efficient. Like a lot of the fancy newer search-based things as well. Um, the code for those is rough. I am starting to believe we might need to scale the model size a bit though for some of these problems. Well, it's funny because like it's the results are very mixed. Sometimes we just solve stuff with tiny policies, and then sometimes we have problems that seem to need the capacity. Right, but just like this reminds me of when people were doing all this crazy ass theory of mind custom algorithm work, and then you look at Dota, which very clearly has theory of mind, and it's just a damn LSTM, you know? So do you actually need the fancy algorithm to learn it, or is it just implicit? Stuff like need is fundamentally compute inefficient for GPUs, which rules it out almost instantly, unless you're also designing the hardware, which nobody's doing. And I don't think it's promising enough to merit that. Oh no, I believe chess is hard, Jess. I believe chess is a hard problem. Oop, let's not do that. What? Puffer 4 already sweeps the number of layers for you. I don't know about the weird conv encoder for chess, though. There it goes. Just an embedding bag. Interesting. But like, Jess, have you been? I thought, isn't there this thing where you can't repro some of the nice scaling results from the conv policy? Like stuff worked with the conv policy that doesn't work as well now. I'd destroy my code base overnight, more like it. I'm trying to think what would be this thing. Right, but what's the point? Like, what's the point in having something write a bajillion lines of code that you're not going to be able to like? Eh. $362 logs. So this is better than before, but still, it's like huge gap. Lowest hook. Okay, that's good. Oh, the conv policy may have been slightly worse. Okay, well, that's good then. If you don't need comms, it's way better. If you do need comms, then we have to deal with shit. If we just leave it on defaults. Fuck. Hmm. Oh, the thing is, this is now non-stationary, isn't it? Is there a way to get a stochastic environment that isn't like crazy non-stationary? I mean, without having to, like, you'd have to pass your logits, wouldn't you? Carpool doesn't have a stochastic optimum policy. You can solve carpool with zero entropy. 5,000 TPUs. Well, but the thing is, we don't need to make the best chess, like, bot in the world, Jess. Like, can you get 2K ELO without search? Hello, welcome. Yeah, Jess. That's pretty cool. That's very cool. What do you think? There's got to be a simple way to do this, isn't there? If it could see your logits, it would be easier, wouldn't it? Do we have any way to make it see your logits? I don't think we do, right? You just pass the actions back. I want an environment that is not non-stationary, that has a stochastic optimal policy that's not the uniform distribution. Can you do that, or do you only ever get stochastic policy or like optimal policy on non-stationary ends? Hmm. 10 million params we can definitely run reasonably quick still. The thing is, a boss fight with random timings, Arch, that's still not a stochastic optimum policy, because it's still deterministic conditioned on the obs. Multi-stage prisoner. I still don't think that's stochastic, is it? The optimum? Particularly not against a static opponent. Maybe this is the right end. Maybe it's just not learning correctly. Poker. Yeah, you're giving... These are... These are non-stationary because they depend on other distributions of opponents and learning opponents and whatnot. That is closer, isn't it? If I do 200, does it, like, fuck up? Huh? Oh, wait, hang on. Okay, that's actually quite close. I think that this works. The optimal policy of this env is a little noisy, but it should be to play action 0 75% of the time. I think this is fine. $400 experiments. Next thing. You don't have to play random against a random opponent. Okay, so we got memories to cast. So we got the sanity M's. That's easy. We'll clean them up and stuff, but those are nice to have. Dokabon. And then the next state set thing as soon as we have the current set of results. Which I think we're fine on. I think we can... We'll go pull them in a second and make sure. But I think that we have enough of them that we can launch the next set. Let me use the restroom. I'll be right back. I figured out how we're gonna go about this. We're gonna make this a little bit more interesting, and we're not gonna just be waiting around for another sweep. All right, this is what we're gonna do. All right, so we got this, and now, oops, yeah. So we have to go here, and we have to set SCP. Oops. Hey, yo, fucking terminal, piece of shit. All right. Yo, why does this break my terminal, huh, Microsoft? What the fuck? Fair enough, Jess. I mean, this is just old desktop. All right, so now what we do... This is a Ubuntu container on WSL, and then all the dev you've been seeing me do is either on a 5090 Ubuntu machine or the 6 GPU tiny box. Okay, I mean, this is a little bit closer at least. Particularly in steps, but yeah, it's not great, right? So I guess what we're gonna do now... I mean, we can just take this. This is the plan. We take this one here. It's supposed to get 251, right? Password. Jess, have you tried fucking right off? I don't feel like reinstalling this desktop. It's got a bunch of old crap on it. And it's the summer, and I like to play a game of League once in a while. Thank you very much. We not. Oh, I see the problem. If you give me Dota that doesn't have 10-minute lobby queues for new and low elo players, then sure. I do mostly play RuneScape crit. In fact, here's the side monitor. 400k off 97. How big were your sweeps when you did more? Like, I ran that stuff for days and days, Spencer. I think most of the experiments, it was thousands of experiments trying to find better params for neural MMO, and I couldn't figure shit out. Yes, I tested that, Spencer, and they are. It's annoying. Yeah, it's very annoying. Okay, so this is 33 seconds to solve. Let me just real quick. Entropy coefficient is maxed. Hmm. 0.2 entropy coefficient. Hmm. That's nuts. That's the only thing I could think of, right? Would be the bias. See, this still underperforms, which is ridiculous. Why don't we do like this? We do 0, and we set it to 100K. Does this totally screw us up? Thing. Okay, so this does not mess up training, right? What happens if I set this? This still screws it up. Well, this doesn't seem possible to me. Mm. That'll mess with it completely, huh? Maybe something around the horizon of the sets. I set the problem up wrong somehow. Okay, this converges. Possibly even a little better than before. The 100K states. A million steps. Curious, isn't it? So, yeah, the base algorithm. We got a couple super low. And then we get mid-range. So we don't actually see the super high prioritization in here. What about beta? Beta gets annealed. Actually starts very high as well. Hmm. That's sketchy. TLDR on what's being made here. This is the next block of research for Pufferlib, which is a high-performance reinforcement learning library. This is currently algorithmic research on whether we can set simulators to specific states during training in order to vastly improve performance. And I'm kind of running some experiments on this password guessing environment that I've set up as a synthetic test benchmark. But that's a super quick version of what's going on here. Maybe this prio alpha gives us a clue of some sort, right? I'll try something. So what if we do like this? We set the CL frac to 0.8. Does that do anything for us? The puffer on the left, that's our mascot. Okay, I mean, this is kind of interesting, right? We get 225. What do we get if I set this to 0? I'm just curious. God damn. Dang. You gotta be kidding me. This thing does is just as good, if not better, with no prioritization. Really. How? Like, what? How? I mean, it takes 200 million bloody steps, right? The whole theory here, right? 26. The thing is, like, it's just weird to me because doing this makes a ton of sense in my head. And this is just worse, somehow. I mean, this is the task where you would do the CL, isn't it? Or did I mess up the task definition? Did I mess up the implementation or the task definition? Let me think. I mean, I guess you don't have the sampling correction. But you basically do the same thing with the annealing. Okay, so this actually works. They're massive perf boost, though, man. Like, okay, I mean, theory, right? It just comes up with some wacko args. You try with defaults. Okay, yeah, defaults, right? So like, let me just play with this. Let me play with this problem a little. It's usually a waste of time to do this, but like something is very screwy and I don't understand what. We'll keep this horizon. And we will keep this off for now. We have a ton of time steps. So just okay, so the default here just fails instantly with like no entropy. That's interesting. I wonder what it is that's like causing that. We have this crazy entropy coefficient. Wait, it's determinizing very quickly even with a 0.2 entropy. That's wacky. That's wacky. That's like that's insane. Of course, you can't learn anything with an entropy coefficient of 1. Hmm. Why would it determinize so quickly, though? Hang on, that's suspicious, isn't it? I mean, I guess that's the problem. Like, you know, you start... The hyperpram stuff is just so powerful. Hmm. It's crazy that you just solved that with hypers, man. Let me double check. The memory thing. It came up with, like, this task actually just hard fails with defaults. It came up with some crazy hypers that solve it with the standard algorithm. Wait, hang on. Hang on, I think I'm conflating shit again. Yeah, shit. It's the task def, isn't it? This does just become a memory problem. And a tough one as well. I think this should work. I think this env is fine. The more I'm thinking about it. What the hell's wrong with the CL? This is just a basic env for like guessing a password. The point is that like you have to restart from the beginning every time you make a mistake. So the point is that if you're doing state sets and you get to start from later into the puzzle, or later into the problem, it should be massively more effective. Stuff isn't working right. It's very odd. Super screwy. Well, I wonder, hang on, maybe we do have like some weird boundary condition. That's at least something. And then we get entropy collapse somehow, right? But like the normal prim doesn't work. Yeah, I mean, this is supposed to be a clean test for Go Explore. It's not doing it. Okay, I mean, this helps. But it's still very bad. And then we have these screwy ass hyperparameters that somehow solve the whole task with no curriculum. Not even implicit. I mean, I guess I could do this. But this is like not super meaningful now, is it? It doesn't even help on the like crappy easy case. This has got to be 100% skill issue, no? Mm. I mean, stuff like this working. This feels like we have some very deep algorithmic problems, honestly. And we're papering over them with massive hyperparam sweeps. But those hyperparams are being abused and not used in the way they're intended. Arch, this is now the 5th time this has been brought up on the stream. We have a benchmark. The benchmark works with crazy, insane, screwy hyperparameters. If I do this. This is like pretty reasonable, right? No, we'll get it, Jess. It's just screwy M stuff. I'm not understanding this full-on entropy collapse, though. Okay, there. This M needs, like, stupid high entropy, sure. That's at least, like, a reasonable baseline, right? Now let me see if I can do anything from here. Yeah, good enough, Arch. Really unstable. Huh. We did get soda, though, is the thing with it. There's signal in here somewhere. So fucky, man. Like, why? If I take it off, it works, right? This matches, so the state sets are fine. No? Well, then this just means the whole thing is fucky. Like, what am I supposed to do with that? There's no way that that should... Oh, it's just, like, super fiddly, huh? Interesting. Yes, there is, Jess, but I'm annealing it out over the course of training. Okay, I suppose, hang on. What if I do this one? I have a massive entropy coefficient on it. Yeah, see, now this does better with absolutely no curriculum. I mean, these entropy coefficients already nuts, so... I think we're conflating other stupid problem setup things with the actual task we care about. I mean, because this is so obviously horribly fiddly here, right? Yeah, Jess, it gives really bizarre results. Like, it scales cleanly with compute, but the hypers are insane. Well, this is a waste of time. Let me think what we can do. There's basically no way in hell this doesn't work. Is this not the ideal task? I'm not gonna go implement like a much more complex env, Jess. Like, any of those work technically, Jess, yeah. But I think you're basically, the thing is, I think you just end up training a perfect policy on the early levels of that. It ends up being like Enduro. I mean, 2048 is interesting for this, right? But, like, that's too big of an end. We should be able to get something on a very clean test bench. And I guess the structure of the obs, like, there are a bunch of conflating issues in here. Is there anything I can do that's even cleaner than this? We kind of do the full thing around here. No, rollouts are technically done async, but the training is synchronous. So it's like both. The rollout workers are asynchronous with each other, but then the training step is synchronous, so the data is still on policy. Okay, maybe we need to do more on this, like, password env thing. I think there's too much crap to remember, maybe. Yeah, there's too much crap to remember. And the obs are weird. It's a little more complicated than that, Jess, because that also increases the amount of crap to remember. And everything I keep coming up with, it's like, nope, that's going to be too easy for the baseline. What are we working on here? This is an algorithmic change that relies on setting the simulator to a specific state during training. The goal is for like very long running tasks where failure resets you. You should be able to learn to automatically resume at parts that you need to practice. I'm having a lot of difficulty coming up with clean standalone tests. Um, the problem is our base algorithm is very good, and two of the tests that I've come up with so far that I thought would be basically impossible, it just fully solved after a hyperparameter sweep. State-based snapshotting. High perf plus moves. I mean, it's good to have strong baselines, right? But it's just like, I mean, this thing, you give it a bunch of increasingly difficult mazes in a row, and it basically gets soda. See, what you need is you need a task that, like, it needs to take a while to do it, I think. Okay, you know what? The obs that I've come up with are stupid here. Yeah, the obs I've come up with are stupid. Too complicated, Spencer. We need a simple test env. The thing that's stupid is, like, you're just changing... It doesn't matter that you tell the agent the passcode. It can't learn... It's impossible for it to learn an arbitrary copy function based on that form. And basically, you're just confusing it because you're changing a very small portion of this state. So what you want, basically, is you want an env that's not terribly difficult to learn necessarily, but, like, it requires some exploration to make progress, and then getting back to that point takes a long time. Okay, look, the obs are way better. Yeah, those obs were way better. Okay. Let's take the exploration crap off for a second. Why is that so unstable? Why is that so freaking ludicrously unstable? Like, what? The entropy is insane. Hang on, maybe... I bet you I know what that is. Yeah, okay, so the entropy loss is just misleading here. It's very low because, like, it's going to basically be 0 up until you get to a state you haven't been in. So, okay, this is fine. This is stable. Now, if I do this... What happens? Okay, that's more like it. Now we'll see whether this is a fluke or not, but that's what we would expect out of CL. So, like, let me see if I set this to 1.0. Let's first of all see if this is unstable. Okay, you know what? Fine. I'm willing to believe that this is too aggressive. What about like 0.8? Is this still fine or no? Nope. If this is better, then I'm going to be annoyed. Okay, it's not. There's some more we need to investigate. Okay, you get something that's quite weak without prioritization at all. Now, if I put the state buffer stuff back in, what happens? God damn. How many states is this? Not very many states. Maybe it's just crushing training diversity. Okay. Very fiddly, though. Mm. It's just far too sketchy, isn't it? It's all coming down to the stupid entropy coefficient. Yeah, there's something weird with the entropy on this env. Super damn unstable. These episode lengths are tiny. Like, I don't know why I'm like, am I an imbecile? Why am I testing with episode length this small? Yeah, this is dumb. Okay, awesome, Valo. Best of luck to you. And there will be cool things soon after. I will handle stressing over figuring out what the fuck is wrong with this stupid thing. Okay, this is better, right? 67. Okay. Try this. Yeah, super janky. So, let me try something else. I just take this off, what happens? Still stable, right? This should be the ideal test case. I doubt this helps, right? Super unstable. I'm trying to figure out what the fuck. Like, this should work. Oh, I bet it could be the LSTM state shit. This is, okay, we have to figure this thing out. Like, double check. That would just be a straight bug that I missed. We still do have soda, so there's something here. Hmm. Okay. Can try that. Isn't this how I did it for prio filtering? Let's try this first and then double check this against prio. I think I might have just misremembered how I did the filtering version. This can't be a problem with the idea. This has to be like a small implementation thing because like there's no way that you don't derive benefit from state set. Okay, that's interesting. Was too biased maybe. Yeah, it's even worse. There's a restroom. I'll be right back. Okay. I got more ideas. I got more ideas. Okay, so 68. Unstable. Few small things. Bet I've been live for 5+ hours. If this small change messes up the non-state based stuff. Nope. Yeah. I mean, the state sets for the end of being broken would explain it for sure. Oh, cool. And we have the chess training to I think he I don't think he PR'd the encoder architecture though, Bet. Like, chess needs its architecture. I'm trying to think what else would cause that. It's kind of weird. I'm testing state sets, and we had some really good results, but now it's being fiddly. I'm trying to create like an ideal test end for it, and I'm having trouble with it. I've gone through this several times, Bet. So we have the algorithm. The algorithm lets you save states of the environment and then restore them in order to run the policy on them. So the idea is that you store states, you figure out which ones are high information, and then you jump to high information states. But we're having difficulty even under the ideal case here, even though we saw like very good evidence from it before. No, it's not eval specific, but something's off with either the algorithm or what I'm doing or something. It's more than just prioritized replay. It's state sets. We had prioritized replay. Now it's locked to 4. And it learns a little bit at the end. But I think something is just implemented wrong. There's no way they should possibly... Oh wait, no, that's the original. The fuck? Hang on, would this change? Oh, why would you one-hot that? We got soda on 2048 in literally the first thing that I ran. Yeah. And also it worked like it worked with hyperparameters that were very strong evidence yesterday. But the problem is the hyperparam sweep stuff is like just really good. So now it's finding all sorts of crazy hypers that make it work as just as well with the original algorithm. But it's kind of just obscuring the real problems. Like Puffer 4 is just too good. Okay. Interesting. Very confusing, Jess. I'm trying to think what the hell this would be. Hmm. Okay. That's fine. The same. We'll trust that from 3-0. Crazy unstable bullshit, right? If the main training is still crazy unstable. A little better. Okay. This is something. Maybe. Like this, the thing is, this algorithm should just crush. It should not even be remotely close. Um, it should just crush. I'm trying to figure out why. I mean, this is the same thing we use for prioritized experience replay. Okay. Sum of abs of advantage. Vapor apparently has some metrics. Hmm. This is reasonable. But the value loss is near zero, right? Is what you'd expect. Jogging is good. Means only about halfway through. Okay, so that'll probably hurt, right? This is just quick logging. I really don't care about the models, but I'm trying to figure out the problem. It's just logging. See, like, the thing is, this algorithm, it should be 10x better instantly. We'll see this in a second. Spam. Any of this pushed? It will be. Once I'm done making a mess. Try this one. Make sure we get the right one. Okay. That's something. Just gonna run it one more time to see if it shifts it even more. See if what happens when we do priority in here. Prints are really annoying. Most likely this oversamples and messes it up somehow. Yeah. Okay, what happens if I don't anneal the CL? It just breaks. Lovely. Somehow just breaks. Million states probably also breaks. Let's see. Yeah, also breaks. Presumably it's something with the data mixing. Five zero. So I am, like I said, I'm doing more stuff. If we're fucking this up, it would do it. That's the only thing I can think of, though. What? The new RSN. You have a salamander? That's funny. Current updates and fresh dates. Hmm. This should be so stable. Like, what's wrong? Maybe we just do like this and this. For fuck's sake. No, Jess, stuff is weird. Like, this should just be incredibly stable. It should both be fucking annealed, is the thing. Like, I would think that the correct thing is this, this, and this, right? And then also maybe this. This is so disappointing. Like, this should just be the most powerful technique ever immediately. Stuff. How did this get set to fucking 7? Hang on. Fuck's sake, man. This shitty. No, it's just a typo. I meant to type 0.7. See, this is fucking garbage. Like, I'm gonna go insane with this thing, like just appending G to the start of every fucking file. Or pre-appending G. That's not me hitting G. That's fucking Vim or whatever Windows terminal this is. Yeah, I know. That's just because the this curriculum method is not optimized yet. Yeah, this thing gets 85 somehow out of the box. So if I just do like this, no other parameters. God damn it. This should be stable. Okay. That actually does work. So for some reason it's a little unstable, but this does work. 94. Oh my fucking god. That's very heavy prioritization, to be fair. Am I double correcting? Yeah, that was it. It was stupid Semshi. Fixed. Jumpy, but it's better. It also gets less data at the start, to be fair, with the CL on. But I mean, still, this is not the, like... This thing breaks it, doesn't it, if I just increase the size? I thought we were done with this G bullshit. I guess we do kind of just, like, go through a lot of states. What if I do 10K in the meantime? That's probably too small, right? I don't like this. Why is it so brittle? Exactly. I don't like that, but we'll try it real quick. What? Yeah, there's a lot of shit with this algorithm. The thing is, this is in dev. Like, it should be very, very stable in theory. Like, this should insta-solve. Actually, it's too well defined. I wonder if 2 is well defined. It crashes. Damn. Works and then crashes. Shouldn't be anything with the LSTM state, right? Yeah, just that's a little high. What could I have possibly screwed up in this algorithm definition? This seems like it makes perfect sense. Do I need to run ablations on the environment? Oh, geez. The stream is not exactly always G-rated when I am frustrated, but I see. You can do whatever with it, Jess. All right, here's what we do. Boom, boom, boom. Boom, okay? This trains instantly, right? %95% trains instantly. Wait, why isn't this instant? This could just be a small model and whatever the hell. Huh? Well, this one is just one level. The one reward in 32 steps is reasonable. Oh my gosh, I have created a fucking cult in the Discord. What is this? Okay. Oh wait, I know what it is. Do I? No, this is fine. Go. Hmm. 97 should be good enough. Now what happens if I do this now? Interestingly, the CL actually does do better here. Interesting. Higher SQL and database queries. I'm gonna try this again with much shorter horizon. And essentially what we're gonna do is we're gonna hope that the we're gonna essentially hope that this like the batches were very low signal because of the massive weights. And it was looking fine and it's just unstable. So obnoxious. Why should that hurt? It really shouldn't, right? That should get you fresher data, if anything. Hmm. Even more unstable, huh? Okay. 8. I do too, though I don't know if it's just hypers being weird. The problem is if I sweep. Yeah, so why is Horizon 8 just bad? Oh, Horizon 8 is probably just bad because say about that. At least more reasonable. Just very noisy, I think. Very difficult to draw conclusions. But I do think there's something to this. Oh, hang on. You commented everything. It should be like this, right? No, this crashes, huh? Super jumpy. Very unstable at short horizons. Try this end real quick. Maybe the incremental maze is better, we'll see. See about prio alpha and beta. This might be overkill. Hello, welcome. They're getting better and they're still stupid. Well, at least adding the curriculum here didn't hurt. Didn't help either, though. Not ideal. Like, how can that not help? I'm seeing like flashes of brilliance, and then it's broadly just not doing. I'm not seeing like the 10x that it should be. It doesn't matter. I decided I felt like I didn't feel like giving Anthropic any more money, so I'm all using Codex. You have a bunch of companies building identical products. Okay, a few more of these little experiments we can do. We also get to 41. Do we do better? Almost. Okay, we get to 43. Get to 44. Get almost to 45. Interesting. Would that have worked without the curriculum? Or is curriculum... Is this gonna give us like a replacement for Oh, but this is still prioritized. It's just less prioritized, isn't it? Yeah, okay, hang on. What if I do it like this? Fucking header, stupid ini file. Anthropic has the very dangerous combination of thinking that they're very good people and being incredibly out of touch. Okay, so it is possible we need to just retune some hypers. Yeah, so 41, which this is match. Let's see what happens without prioritization. And that's precisely the reason, Jess. All right, so we'll do this, and we're gonna see, does it just still get 41? Well, this is just bullshit, isn't it? I gotta leave in a bit. This is baffling to me. Like, how? Right? Not an env bug. Now multiple envs. Vempig support. I think that's how you do it, Arch, unless Rayson doesn't have a native way to do headless video, does he? If he doesn't have a native way to do it, then yeah, you just pipe it to f of mpeg. I'm in Palo Alto. This is an old desktop and I don't feel like reinstalling it. I'm SSH'd into Linux boxes for dev anyways. got removed in 6.0. Oh, come on. Wait, did he remove his gift saving thing? I like that feature. Bro, it's like my favorite feature. All right, well, we'll have to open a thing on it. Like, that's the best feature ever. Well, I'm the only one who used it because it's not like he doesn't advertise that it exists anywhere. Yeah, he literally posted about it once. That's how that's how I know it exists. I had to go in like 10 minutes. It's very odd though. Ah, now probably it breaks it. We can just include the .h. Unless I remove this, but I'm pretty sure we do with 0. Yeah, ffmpeg will work. And then the question will be whether we want it as GIFs or whatever. Yeah, ffmpeg would be good. And the fastest. I believe there's an example in Puffer Drive of like piping it to ffmpeg if you haven't already done that. All right, that's good, Arch. I gotta run to dinner, and if you, I want to finish my thoughts on this. It's like this is gonna bother the crap out of me all night, I'm sure. Um, I'm gonna have to think about it, Jess. Let me see what this does real quick. What happens if we leave them both on? Hmm. Hmm. I don't understand how it is that like we get from this to yeah, Puffer just solves it with no curriculum at all. Is the model just that much better? It's tricky. Well, it's equal now, Jess. But then this is like weird because this is a super curriculum heavy env, or it should be. I mean, okay, one thing we could do. Could try it on Maze. Maybe incremental, like incremental Maze is a new env. And yeah, it's based on my old one, but I don't, like, we shouldn't have as much trust in this as we have in our old env. Thank you. I'll continue to mess with this a little bit, folks. I just want to try out like the standard maze, with the standard hypers, and a few permutations of adding curriculum to that, and we'll see what we get from that. I mean, the thing is that it really, really should give us a huge, huge difference in perf. And the fact that like the implicit prio isn't, like, I know for a fact that there were many M's, Maze at some time included, where this was a huge difference. So I guess it's possible that our architecture just got ludicrously stronger. But we'll have to figure all that out later. In any event, for the folks who've been here all day, thank you for tuning in. We're going to still be doing this for all this week, all next week, right here. If you want to help me out for absolutely free, start the Puffer, puffer.ai. This number helps us out more than you'd expect. This means I don't have to spend my time writing Twitter bullshit and advertising. And more companies just see Puffer, and we get contracts, and I spend more of my time on R&D. So go ahead and do that. Join Discord if you want to get involved. Follow on X or